Scientists just saw something from the sun we were never supposed to see with a telescope from Earth. The sun's inner corona, the region where its atmosphere explodes outward into space at temperatures over 1,000,000 degrees. And it changes how we understand the sun's magnetic field, the solar wind that reaches Earth, and the space weather that can disrupt our entire technological civilization. The images come from the European Space Agency's Solar Orbiter mission, in coordination with NASA's Parker Solar Probe. Solar Orbiter launched in February 2020 and reached its science orbit in 2021. It was designed to study the sun up close, reaching as close as 42 million kilometers from the sun's surface, about a quarter of the Earth-Sun distance. More importantly, Solar Orbiter carries a suite of instruments optimized for extreme ultraviolet and X-ray imaging, including the Extreme Ultraviolet Imager, or EUI, and the Spectrometer/Telescope for Imaging X-rays, or STIX. On June 18, 2024, Solar Orbiter executed a close approach to the sun that brought it within 80 solar radii of the sun's surface, roughly the distance where the solar wind transitions from subsonic to supersonic flow. During this period, the spacecraft's instruments captured high-resolution images of the inner corona, the region just above the sun's visible surface where magnetic loops arch, reconnect, and release vast amounts of energy. What makes these observations unique is that from Earth, the sun's bright photosphere overwhelms the much fainter corona. We normally only see the corona during a total solar eclipse when the moon blocks the photosphere or with specialized coronagraphs that artificially block the sun's light. Even then, coronagraphs cannot see very close to the sun's limb because stray light hides the inner corona. Solar Orbiter's proximity and its unique viewing geometry, combined with its ability to image in wavelengths where the corona shines brightly, allowed it to see structures in the inner corona that are usually hidden. These include the very footpoints of coronal loops, the precise locations where magnetic reconnection occurs, and the initial acceleration region of the solar wind. The data confirms that the solar wind is not a uniform outflow. Instead, it is highly structured, originating from discrete regions where magnetic field lines open up into interplanetary space. In some regions, the wind accelerates rapidly over a short distance. In others, it remains trapped in closed magnetic loops that trap plasma and heat it to tens of millions of degrees. Why does this matter? Because the solar wind is the driver of space weather. When coronal mass ejections, massive bursts of plasma expelled from the sun, erupt and travel toward Earth, they can trigger geomagnetic storms. Those storms can induce electrical currents in power grids, disrupt satellite communications, and expose astronauts to dangerous radiation levels. The better we understand the inner corona, where the solar wind is born and where solar flares are triggered, the better we can forecast the arrival time, strength, and magnetic orientation of these events. Right now, our forecasts are good, but not good enough. With this new imaging capability, scientists expect significant improvements in predictive accuracy over the next few years. Solar Orbiter is continuing its mission into the late 2020s with increasingly close approaches. Each pass brings new images of the inner corona at higher resolution and from different viewing angles, building a three-dimensional map of the magnetic field that drives solar activity. The sun is not a static ball of gas. It is a dynamic, magnetically driven star that shapes the environment of the entire solar system. For the first time, we are finally seeing the engine room. Follow for more space discoveries that connect directly to life on Earth. And tell me, knowing that the sun's inner corona can now be seen up close, would you want real-time warnings of solar storms, the way we get hurricane warnings?